What if you fell into the sun? Most people imagine a long descent into a fiery ocean of plasma, but the star destroys you long before you reach the surface. Right now, you are sitting on a planet that hovers at a comfortable, life-sustaining global average of around 20 degrees Celsius. That comfort is dictated by geometry. Earth sits precisely 150 million kilometers away from our local star. But the space between us isn't just empty. It is flooded with intense thermal radiation, heat and energy projecting violently outward in all directions. If you were to slip out of orbit and fall inward, the journey itself becomes the hazard. That massive distance is a countdown, marking exactly how long your biology can hold together. The descent begins as you leave Earth's orbit behind and start the plunge across that 150 million kilometer void. By the time you pass the orbit of Venus, the ambient heat has reached a level high enough to melt lead. Keep falling and you pass Mercury. Beyond these stark gray craters, you leave the final planetary milestone behind and enter fully open solar space. This chart shows the physics of your descent. Because of the inverse square law, every time you halve your distance to the star, the intensity of the radiation quadruples. The line representing thermal energy shoots upward at an ever steeper angle. When the trend line hits this mark for biological failure, the sheer volume of ultraviolet and infrared energy causes human skin to blister and burn in the vacuum. On Earth, the atmosphere filters out the worst of this energy. Out here, your cells are stripped of that shield and take the full, unfiltered brunt of the star's output. Millions of kilometers before the surface of the sun is even visible in close-up, human biology reaches its breaking point and fails. Roughly 3 million kilometers out, you cross a final physical threshold. The liquid water inside your body boils and flashes into vapor, triggering a systemic collapse of your cellular structure. You no longer exist as a physical person. All that remains is a loose cloud of vaporized atomic traces, continuing the plunge. Those traces continue their freefall until they finally impact the photosphere, the outer layer of the sun. Here, the temperature rests at 5,500 degrees Celsius. This is an environment of magnetic violence. These dark patches of churning plasma are governed by twisting magnetic fields that rip matter apart at the molecular level. Gravity now seizes your remaining atoms and drags them down, deep into the star's interior. In the core, the heat spikes into the millions of degrees. The pressure is so high that hydrogen atoms are crushed together to form helium, releasing energy through nuclear fusion. Your atoms are integrated directly into the star's nuclear fuel source, recycled into the same engine that powers the entire solar system. You are now an indistinguishable component of the solar engine. This same fusion process that consumed your body is also the sole energy provider for every plant, animal, and weather system back on Earth. The radiative energy that sustains every ecosystem on our planet is incompatible with complex biology when the gap is closed. Our safety is reliant on a narrow cosmic margin of 150 million kilometers. Life exists in a fragile balance against the immense forces of the universe. To explore more of them, subscribe below.